Hi everyone, this is just a review of sequences and series. So probably you should watch the other videos that separates out arithmetic and geometric sequences and series. So this is kind of a review of all of it put together. So these are type of test questions. Find the first 5 terms of the sequence and find its 10th partial sum. So what I'm going to do is plug in, I need ace of 1. Let's scoot over here. Ace of 1, ace of 2, ace of 3, ace of 4, and ace of 5. All right, and I'm going to just use this formula here. All right. And so everywhere my n is 1, 2, 3, 4, and 5. It's called the nth term. So we're going to just say 68 minus 3 times 1 minus 1. 1 minus 1 is 0. So 68 minus 0 is just 68. That's your first term. The second term would be 68 minus 3 times 2 minus 1, which would be 68 minus 3, which is just 65. All right. Let's try a third one. We have 68 minus 3, and I'm using these. Remember, these numbers match. These are called index numbers. They're very important in our finding patterns and everything. So we get 68 minus 9, which minus 6, sorry. And that gives us 63. And I think what you're going to find is, there's 62. And I think what you're going to find is that we keep going down by 3. We keep subtracting 3. So all we have to do is keep subtracting 3 here, and we'll get 59 here. 59 minus 3 is 56. All right? So you keep subtracting 3. Now they want let's find the 10th term. So the 10th term would be 68 minus 3 times 9, basically, because 10 minus 1 is 9. So 68 minus 27 equals 41. And if you want to do just the sum of all this, it would be the sum of n, so that would be, we're doing 10. And our formula is n over 2, and you add the first and the last term. So this would be, our n is 10, so that would be 5. 10 divided by 2 is 5. And then we're just going to be adding 68 plus 41. And I haven't done this one yet, so let me do it real quick. 68 plus 41, and then you times that by 5. You get 109. So that's 5 times 109, which equals 545 if they want the sum. All right. Now, the next problem is just asking you how to identify arithmetic and geometric sequences. So first of all, sequences, how they are alike. Sequences are a list of numbers. You don't add them. Series is where you add them. It's the sum. So they're just asking about sequences. It's a list. The arithmetic has a common difference. That's why D's in the formula. That means you're adding or subtracting to the term before it. And geometric has a common ratio. That means you're multiplying it by a number before it. Okay? The arithmetic ones are linear in nature, and the geometric are exponential in nature. Okay? Now, how are they alike? They both have a first term, and they're a list, and you can find the patterns very easily. And I'm sure you can find more similarities and differences. All right, next. It says list the first 6 terms defined by the explicit formula use of n here. So basically, I just plugged in I want use of 1, use of 2, and so forth. When I plug in 1 here, I'm going to get 1 times 0 times 2 over 3. Well, 0 over 3 is just 0. So my first term is 0. Then you plug in 2. So that's 2 times 1 times 3 over 3. So that's going to be 6 over 3, and that equals 2. Use of 3 is going to be 3. And all I'm doing is I'm going down 1 and then up 1 here. And that's going to over 3. That cancels, the 3's can cancel here. So that just equals 8. Use of 4, I'm kind of running out of room. It's going to be 4 times 3 times 5 over 3. So the 3's cancel and we get 20. Use of 5 is 5 times 4 times 6 over 3. 3 goes into 6, 2. So 2 times 20 is 40. And the last one is use of 6, which is just going to be 6 times 5 times 7 over 3. 3 goes into 6 2 times. 2 times 35 is 70. So that's just 6 terms. Pretty easy. Now we have to write a formula for this. So where is it? Okay, I have it here. What you want to do, first of all, is list this. So, and I kind of made it too close here. This is ace of 1. So let me do it this way. Ace of 1, ace of 2, and so forth. I made these numbers too close. So basically what I'm going to look at is, I noticed that ace of 1 is 2. All right. Ace of 2 is 5. And we can write that, you see this 2 here, we can write that as 2. I want to look at the previous term here. 2 plus 3. Because I want to use this previous term. So now ace of 3 is 10. So my previous term is 5. So I'm going to write 5. 5 plus what is 10? That's 5. Now I'm using ace of 4. So I'm using my previous term, which is 10. And how do we get to 17? We add 7. I'll do it one more time. All right, ace of 5 is going to use my previous term, which is 17. And how do we get to 26? Well, we're adding 9. Now, what you notice is that we keep adding odd numbers here. So the formula for an odd number is 2n minus 1 or 2n plus 1, depending on where you're starting at. So what I did is basically go ace of n equals my previous term plus 2n minus 1, or vice versa. So let's see if ace of 2 works. And we're just going to say our first term is 2. So ace of 2 is my previous term, which is 2 plus 2 times my previous term is 2 minus 1, which is 2 plus 3, which is what we have here. And if you want to try again, we'll try ace of 3. So it's my previous term. That's what this means. So my previous term was ace of 2. I'm just going to write this down. Ace of 2 plus 2n minus 1. So ace of 3, my previous term was 5, plus 2 times my n is 3, minus 1. So that gives me 5 plus 5, and that equals 10. And you can keep checking it. But what I had to do here, when I'm trying to find this, I keep looking at this previous term and seeing what I'm adding. And what I'm adding is the odd numbers, odd multiples, okay? All right. This one, we're going to, again, this is ace of 1, ace of 2, and so forth. So what I know is ace of 1. So ace of 1 is 10. You write that down. And then ace of 2 we know is 10 squared. So what I'm going to do is 10 squared. So it's basically what I could say is my ace of n, so far I'm going to keep checking it, is my previous term squared. And what I notice is that I have 1 0 here, 2, 4, 8. So you're just squaring the zeros. So let's try ace of 3. Ace of 3 is my previous term, which would be 100 squared. And ace of 4 would be my previous term, which is 10,000 squared. And when you square it, you're just doubling the zeros there. All right? Now, the next one is a word problem. We have 40 rows, so that basically means we're going from ace of 1 and all the way to what? Ace of 40. And I know on the first row it's 18. The second row is 20. And it says it has 2 more seats, so that'd be 22 all the way down to ace of 40. So we want to know how many seats are in the last row. And you're going to use this formula, which you should already know. So my ace of 40, my n is 40, is 18 plus 40 minus 1 is 39, and my common difference is 2. So when you work this out, you're going to get ace of 40 is 90, 39, yeah. Let me double check here. So we're going to get 18 plus 39 times 2, and that gives us 90. So this is 90. Now, what's the total seating capacity of each of this whole section? So the whole thing. So I use my sum formula. So my total capacity, I have 40 total seats. The sum of the 40 rows, basically, is 40 over 2. And then you add your first term plus your last term. Actually, this was 96, sorry. 96. And 96. And I already worked this out. So you get 2,280. All right. We got 2 more. It says, is this sequence here, 3, 6, 12, etc., arithmetic or geometric? Well, the first thing we notice is that we are not adding, we're multiplying. In fact, we're multiplying the previous term by 2. So what we want to do is find a formula, and our explicit formula you can look at like this. That's your explicit formula. And that should be on your formula sheet. So all you're going to write down is your first term and your common ratio. And your common ratio is 2. So that's your explicit formula. And remember, you can't multiply those two. Now we want to find the 10th term. So it's just 3 times 2 to the 10 minus 1, which is 3 times 2 to the 9th. Did I do this one? Yes. So that's 1,536. So that's the 10th term. All right. It grows, like I said, these are exponential. It grows pretty fast. All right. And the last problem we have is another word problem. Word problems on these are very easy. So basically the first row, there's 10 rows. So we're going to ace of 1 all the way to ace of 10. The first row is has 22 tiles. The second row has 18, and it keeps going down by 2s. So the next one would be 6, going down by 4s actually. So the next one would be 16 and so forth. Not that we know that. There's 10 rows. How many tiles are in the last row? So basically I need to find ace of 10 first. So let's write our formula. My first term is 22. I have 10 rows, so 10 minus 1 is 9. And my common difference is negative 4. No, my common difference is what? Negative 2. Sorry about that. So 9 times negative 2. I think I wrote this down wrong. So that's what, okay, so this is 20 and this is 18. All right. So what you get is 22 minus 18 equals 4. That's what I was thinking of. All right. So the last row is only going to have 4 tiles. All right. Is that all they're asking? All right. If you do want to find the sum of this, the total, how many tiles total, we use our summation formula for arithmetic sequences. And there's 10 total. So that's going to be 10 over 2 is 5. And you add your 22 plus 4, which is 5 times 26, which equals 130. And that's all. Thanks and have a nice day. Bye-bye.